All right, so in this lesson, we are going to solve for unknown side lengths. Solve for unknown side lengths in right triangles. And I will be able to solve for and classify, not classifying, and classify triangles using the Pythagorean theorem. So classify triangles using the Pythagorean theorem. So we worked with this yesterday. I don't know why this is such a delay. Why did you go slower? Okay. Remember that the Pythagorean theorem says that a squared plus b squared equals c squared. Okay, with that being said, let's go ahead and look at this. So it says we want to find this b. So let's label our c, our hypotenuse. And remember, these don't matter. The legs don't matter. So 27 squared plus b squared equals 38 squared. So let me make sure I have this ready because I won't be able to multiply these in my head. So 27 squared is 729. Oops. 729 plus b squared equals 38 times 38 equals 1,444. So I'm going to subtract 729 minus 729. And I get, I'll write it over here. No, I think I have enough space. B squared equals, let's see, 715. Oops. 715. And then I have to take square roots. And so B equals, normally we would estimate this, right? But I want you to see. So I want to see if any perfect squares go in here. So 715 divided by 4. No. 715 divided by 9. No. 715 divided by 25. No. 715 divided by 36. And you can try like some, but it doesn't look like there's going to be anything. So I think that's what it is. B is the square root of 715. So B is approximately, let's see what we can do here. Square root of 715 is 26.74. 26.74. Not too bad. I don't even know why it looks like this. Let me try again. B is approximately 26.74. And this is my exact answer, so I want to box this also. Okay, not too bad. So this is C. We'll make this one A, this one B. So we'll do x squared plus square root of 2 squared. Well, would it make sense here? That looks confusing. Squared equals 4 squared. So x squared stays the same. Okay, this is saying what times what, like, how do I say this? So, oh, this is square root of 2. I was thinking backwards. Square root of 2 times square root of 2. Well, if you're trying to figure out what times what is 2 and you multiply it by what times what is 2, then you just get 2. Remember, this like undoes the square root. Equals 16. Subtract 2. You get x squared equals, oh, that 2 looks a little crazy. Okay, so x squared equals 14. If you notice right here, well, let's do this first. We'll take the square root, right? And so you get x equals the square root of 14. Now right here is when you need to check. So 4 doesn't, for perfect square, so 4, square root of 4 doesn't work, square root of 9 doesn't work, square root of 16 is too large, so we're done here. This is one of our answers. No, that's a little too tall. And let's do square root of 14 to get an approximate answer. X is approximately 3.74 units. Okay. And let's try this one. So this one C. We'll make that one A, that one B. So 5, I'll leave some room. 5 to the second power plus x to the second power equals 5 square root of 2 to the second power. So 5 times 5 is 25 plus x squared equals. So this is 5 square root of 2. Well, I'll put it in a different color. This means 5 square root of 2 times 5 square root of 2. Okay. So 5 times 5 is 25. Square root of 2 times square root of 2 is 2. So we get 25 plus x squared equals 50. Remember that 5 times 5 was the 25. Square root of 2 times square root of 2 is 2. Well, if you want, you can put 25 square root of 4. 25 square root of 4. 25 square root of 4 is 2. Like right there, if you need to see it. And then we subtract 25. Subtract 25. We get x squared equals 25. Oh, and this will be easy. Square root of this. So x equals 5. Oops. All right, next page. All right, so the Pythagorean theorem and different types of triangles. So we have an acute right here, triangle, like this for acute triangles. I'll keep it the yellow. And we'll look at the obtuse. So for acute triangles, a squared, hold on, all right. So for acute triangles, a squared plus b squared will be more than c squared, For obtuse, remember we have an obtuse angle? Okay, let's back up. Acute triangles, these are all acute angles. These are all less than 90. Over here, obtuse triangle, you have one that's larger than 90. The rest can't be, obviously, but this is larger than 90. And then you have two acute. So I'll focus on that. This is the obtuse. Just in case you forgot what they were. And these are acute, like all of these. So in the obtuse, a squared plus b squared will be less than c squared. Okay, so using the converse of the Pythagorean theorem to determine whether, or use the converse, we're going to determine whether each of the following forms a right triangle. If a right triangle is not, tell whether it's acute or obtuse. Oh, I should probably make this orange again. So determine right triangle, acute or obtuse. So here, we'll do 12 squared. We'll do 34 squared, and we'll do 37 squared. We'll add these. So 12 squared, let me make sure I have this ready, is 144 plus 34 is 1,156, and then we have 37 times 30. 37 times 37, which is 136.9. Let's see how these compare. So I'm going to put a box here, pink. Oh, that's not pink. Okay, pink box here. And then we'll add them together. So 144 plus 1156, and I get 1369. So I end up with, so a squared plus b squared is less than c squared. So a squared plus b squared is less than c squared. So this is obtuse. So obtuse. Okay. And then I think you basically get this. You would just see, yeah, I don't know. Let's just do it, the next one. So 6 over 7 to the second power plus 8 over 7 to the second power. And we will see how that relates to we got to pick the longest. Yeah. Always make sure. I'm going to say this in 1 second. Okay. Yeah. Okay. The reason I put parentheses is because then it looks like 6 to the second power over 7, or 8 to the second power over 7, but we want this full fraction. You can turn these into decimals if you want, but I will say longest side will be c squared. Make sure the longest side is always c squared. Okay, so the longest side, that's the most important thing. Longest side, always make it c. Always make c when you test these, because we're assuming. Okay, longest side always make c. I'll show you this last one. I don't think because y'all can turn those into decimals for all I care. But we need to figure out which of these. So we have 20 square root of 42. So I want to do square root of 42. So 42 square root is 6.48. So when I set this one up, it's going to be a 20 squared plus square root of 42 squared. We don't know. We don't know. How does it compare to 21? So 20 squared is 400. Square root of 42 times square root of 42 would give you 42. And we want to know how that compares to 21. Oh, 21 to the second power. My bad, I almost forgot that. So 21 times 21, 441. So let me make sure y'all can see that I did that. So I did this one, I did this one, and then I did this one. And then of course you would complete it. So I would draw lines maybe. So this one obviously goes here. I think if I drew lines, y'all might get more confused. I'm gonna leave it like this. Okay, thank you.